that if we have a right triangle, there are 3 right triangle trig ratios. Sine of theta, cosine theta, tangent of theta. When we go through our little saying,
Please.
oh heck, another hour of agony. So we have our 3 trig ratios. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Remember, hey, are you ready to go, people? Remember that the opposite side and adjacent side all depend on where your theta is. So in this triangle, here's my theta. So this would be my opposite side, right? Hypotenuse is always across from the 90-degree angle, and my adjacent side then would be this. Is everybody comfortable with that?
Yep.
Okay, let's just start. My example's off your worksheet. Here we go. So we're doing number 1. So we're doing number 1 from the worksheet together. It's always across from the 90-degree angle.
And what's the adjacent?
It depends on where theta is. It's adjacent to theta. Depends on what angle we're looking at. So everybody, number 1, here we go. So first of all, we're asked to find sine of A, cosine of A, tangent of A, sine of C, cosine C, tangent of C. So we're looking at a bunch of different sines of cosines and tangents from different angles. That is exactly what you'll see on the end of level test. They'll make you just look at it from different angles. Get in one picture. So don't have to know all the sides.
Yes.
Okay, well we don't have this side. So let's go through and use the Pythagorean Theorem because it's the right triangle to find that side. Remember, the Pythagorean Theorem is side 1 squared plus side 2 squared is equal to the hypotenuse squared. The hypotenuse has to be on the right side of the equal sign.
It's just A squared plus B squared equals C squared.
Yeah, but I write it like this because people get way too caught up in A squared, B squared, C squared. It might be GFD and then they can't do it because they're like, what's that? You get what I'm saying? So side 1 squared. Well, this is, first of all, this is definitely our hypotenuse, right? So that has to go on the outside. So side 1 squared, side 2 squared, it doesn't matter. I'm going to go question mark squared plus side 2 squared. So plus 7 squared equal to the hypotenuse. You have to put this in parentheses. 7 square roots of 5 all squared. Do you all understand? You have to put that all in parentheses. So let's all practice calculating that. So right now I have question mark squared plus 49 is equal to, if you don't type this in right, you'll get it wrong. And nope, so you typed it in wrong. So let's all practice. Parentheses, everybody. Nope, let's all do it together. Put a parenthesis, everybody. We should all be practicing typing it in. Put a 7 in. Then hit second square root. Notice there's now another parenthesis. Put a 5. Close your parenthesis around the 5. Close your parenthesis around the whole thing now. So there should be 2 parentheses at the end. Then hit squared. You should get 245 if you typed it in correctly. Do you all see how those parentheses are a huge, huge importance? Okay. So now we'll just solve for question mark algebraically. Subtract 49 from both sides of the equation. Question mark squared is 160.
196.
196, that's right. 196. Now that's not question mark. We've got to find question mark. This is question mark squared, so we've got to find question mark. So we square root both sides.
14.
14. So question marks equal to 14. So now we found this side. That had nothing to do with right triangle trig, but we had to do we had to do the Pythagorean Theorem first to be able to start. So I write in 14. And now I can begin. Questions? Okay, let's go find sine of A. So now it's a sine of A. So understand, you're going from angle A. So I go to angle A. I'm going to put a star there so I can focus on that angle for a minute. So sine of A is opposite over hypotenuse. So opposite from that angle is 14. Over hypotenuse is 7 square roots of 5. So I have 14 over 7 square roots of 5. Is everybody comfortable up to there? Oh, heck. Now simplify it right here, right now. What's 14 over 7?
2.
This becomes a 2 and a 1. So I'm just going to write 2 over square roots of 5. Now, that answer is not yes. This is A. Sine is opposite. So 14 over the hypotenuse, which is 7 square roots of 5. 14 is opposite over hypotenuse is 7 square roots of 5. Questions? So then from there, I simplify 14 over 7. You get 2 over the square root of 5. We can't have a root in the bottom of our fraction. Remember that?
Yeah.
So we have to rationalize the denominator. So these are advanced problems. So I'm going to multiply the bottom by the square root of 5 and the top by the square root of 5. So on top, I have 2 times the square root of 5, which is simply 2 times the square root of 5, right?
Right.
And on bottom, the square root of 5 times the square root of 5 is the square root of 25, which is? So 2 square roots of 5 over 5, there's sine of A in the simplified form. Next one, cosine of A. Cosine is adjacent over another hour, right? Adjacent over hypotenuse. So my adjacent side is 7. My hypotenuse is 7 square roots of 5. So 7 over 7 square roots of 5. Before you rationalize the denominator, simplify it. 7 divided by 7 and becomes a 1 over 1. So that's 1 over the square root of 5. Then we have got to rationalize our denominator because you can't have a root in the bottom. So I'm going to multiply the bottom by the square root of 5 and the top by the square root of 5. On top, we have the square root of 5. On bottom, we have the square root of 25, which is 5. There is cosine of A.
How did you get 25?
5 times 5. So we have the square root of 25. Okay, moving on to tangent of A. So tangent is, oh heck, another hour of agony. Opposite over adjacent. 14 over 7. So we have 14 divided by 7, which is 2. There we go. And moving on. Now we're going to find sine of C. So now I'm going to refocus, and now I'm looking at angle C. So sine is opposite over hypotenuse. So 7 over 7 square roots of 5, right? Opposite over the hypotenuse. So 7 over 7 square roots of 5. Now look, isn't this what we have right here? So let's not we know what it simplifies to be. It's that. So I'm going to write it. Square root of 5 over 5. Cosine of C. Oh heck, another hour. It's adjacent over hypotenuse. So 14 over 7 square roots of 5. And we've already done one similar to this right here. Sine, up here, sine of A was the same thing. So we went through and simplified it. We get 2 square roots of 5 over 5. And then tangent is, oh heck, another hour of agony. Opposite over adjacent. So 7 over 14. Don't make the mistake of saying that's 2. It's not. It is 1/2. So we went through, we found sine of A, cosine A, tangent A, sine of C, cosine C, tangent C.
Will it always be like Z order?
Yes. Good question. All right. Are you ready to go? Do 1 through 5. I'm only going to give you a little while to practice, and then we're going to move on, and then we're going to do Alex. So everybody should be paying attention, or you're not going to remember how to do these. So it says, let's read the directions. Find the measure of each angle indicated. Round to the nearest tenth. So first of all, you all have to change your calculator into degree mode. Because remember how we reset our calculator in here? Remember the other day when we did that? It's not in degree mode. Because we know if we're finding an angle measure, it's going to be in degrees, right? So everybody hit mode. Hit mode on your calculator. Go. Hit mode. Scroll down where it says radians and degrees. You need to scroll over to degrees and hit enter. Questions on how to do that?
So it's the degrees black?
Degrees need to be highlighted. So hit enter. Then hit second quit. Second quit. So now we're out. Did everybody change it to degree mode? Okay, so now we can calculate this. It says find the measure of the angle indicated. Well guys, the theta is the angle being indicated to find. Do you all understand that? Okay, because that's just like a variable. So it says find the measure of the angle indicated. So we've got to go ahead and set up a trig ratio to help us out here. So first of all, from theta, in this triangle we have the opposite side and the adjacent side, right?
Right.
So the only trig ratio we can use is
Tangent.
tangent. So we know that tangent to theta is opposite over adjacent. Well, that's the only information we're given is opposite and adjacent. So we're using tangent. So now we'll plug it in. Tangent of theta is equal to opposite over adjacent. So the opposite is 12 over the adjacent, which is 10.1. Is everybody comfortable up to here?
Yeah.
Now understand something. Theta is entrapped in tangent. Technically, there's parentheses here. So theta is entrapped in tangent. The only way to get tangent to go away is to take the inverse tangent of it. So we're going to take tangent inverse of both sides of the equation. Now, understand that tangent inverse and tangent cancel out, leaving us with theta on the left. And then on the right, we have tangent inverse of 12 divided by 10.1. So now make sure in your calculator you type in tangent inverse, not tangent. It's tangent inverse. The only time we find take the inverse is if we're finding an angle. So you say second inverse, or second tangent, and then type it in. What'd you get?
49.
Theta is equal to 49.9 degrees. And we just found theta. We're done. That's all you have to do. Now you're not always going to use tangent. What if we were given opposite and hypotenuse? We would have used sine. What if we would have been given on here the adjacent and the hypotenuse? Cosine. So you all understand you have to set up a correct trig ratio. Okay, awesome. I want you to finish 6 through 10. So I'm going to give you 5 more minutes before I make you put it away, and then we'll start working on Alex.